Imagine a Tuesday afternoon. You are standing in the middle of a brightly lit hardware store, right in the center of the pest control aisle. The air there smells heavy, sharp with the scent of synthetic chemicals and plastic packaging. In front of you is a shelf packed with solutions for every creeping thing. You pick up a bottle of ant killer. It costs $15. Next to it is a can of roach spray for $18. You need a flea treatment, and that runs $28. A box of mouse poison adds $12 to the pile, and a specialized bed bug spray tops it off at $45. By the time you push your metal cart to the checkout, the total on the screen is over $110. You pay it because you feel you have to. Pests are an emergency. You have ants trailing across the kitchen windowsill, a single cockroach scurrying behind the refrigerator when the kitchen lights turn on, a flea bite on your ankle from last week, and small, dark mouse droppings in the corner of your pantry. But when you drive home and actually read the fine print on plastic bottles, you discover something deeply troubling. In small block letters, the labels all say the same thing: do not use around children, pets, or food preparation surfaces. Stop and think about that for a moment. The very places where the pests are hiding, the kitchen counters where you chop vegetables, the baseboards where your dog sleeps, the cupboards where you keep your flour, are the exact places where you are told it is unsafe to use these products. Now, let us leave that hardware store aisle behind. Walk with me into my home, right into Esther's pantry. The air here smells different. It smells of dried thyme, cedar wood, and old beeswax. On the third shelf, sitting quietly next to the rows of glass canning jars filled with summer peaches, is a simple cardboard box of baking soda. It cost $4. It has been sitting on that shelf for 9 months, and it is still mostly full. Esther uses it to make her biscuits rise, to scrub the baked-on grease off the stovetop, to take the stale scent out of the icebox, and to keep pests out of every single corner of our farmhouse. Her grandmother used that exact same $4 box for the exact same purposes for 60 years. There is no dedicated chemical aisle out here. No skull and crossbones warnings printed on the back. No need to keep the cabinet locked up tight, away from curious children. It is just one cheap, chalky white powder, soft as flour between your fingers, that has been doing the heavy work of expensive commercial pesticides since long before either of us was born. Understand this clearly before we go any further. Baking soda is not magic. I want to be entirely straight with you about its limits. It works strongly on some pests, it works mildly on others, and on a few, it works purely as an old folk tradition, where the modern scientific evidence is a bit thinner. I am going to walk you through 30 specific applications honestly. I will tell you plainly which methods have the weight of documented chemistry behind them, which ones offer a gentle helping hand, and which ones are old remedies that some folks swear by even if the laboratory cannot fully explain why. This honest scope is necessary. It keeps you from being disappointed, and it keeps our old farmhouse catalog credible. I am Elias Yodar. I am Amish, and I farm the soil here in Lancaster County, Pennsylvania. Today, I want to show you 30 ways to use a simple box of baking soda for household pest control. Every single one of these methods costs pennies per application. Every one of them is safe enough to sit on a low shelf where a child might reach. And every single one has been tested, either by the cold reality of modern chemistry or by 3 generations of daily farmhouse practice. Some of these methods will solve your pest problem completely, right down to the root. Some of them will simply help you manage it. But all of them are worth knowing. By the time we are done, my goal is to help you replace at least half of those heavy, expensive plastic bottles under your sink with one single $4 box. Why do we pay for these chemical bottles year after year? How did our grandparents keep their homes clean and safe before those chemical companies existed? The answer lies in understanding the material itself. Let us look at the plain chemistry of how baking soda actually affects a pest. Baking soda is sodium bicarbonate, a mild alkali. When you hold it, it feels cool, dry, and clean. But to a small insect or a rodent, it is a completely different substance. It works through three distinct physical mechanisms. And once you understand which mechanism applies to which creature, you will know exactly what to expect. The first mechanism is gas buildup within the digestive system. This is the strongest and most lethal way it works. When an insect or a small rodent consumes baking soda, the sodium bicarbonate immediately encounters the highly acidic environment of their stomach. That contact triggers a rapid chemical reaction, releasing carbon dioxide gas. In our baking, that gas is what makes dough light and airy. But inside a small creature with a rigid exoskeleton or a primitive digestive tract that has no natural way to expel or burp up gas, that internal pressure builds rapidly. The pressure expands until it stops their systems completely. This is a powerful, undeniable physical reaction. It works with great force on ants, cockroaches, and fire ants, and there is evidence it affects mice and rats in a similar way. The second mechanism is simple dehydration. Baking soda consists of tiny microscopic crystals. When these dry crystals come into contact with the protective, waxy outer layers of small, soft-bodied insects, they begin to draw out moisture. Over hours and days, the powder absorbs the essential fluids the insect needs to survive, leading to fatal dehydration. This is a slower process than the gas buildup, but it is entirely real. It is how we handle fleas, bedbugs, silverfish, and the small larvae that hide deep within carpets and floorboards. The third mechanism is alkaline disruption. Because baking soda has a high pH, it is naturally basic. When it touches a pest that relies on a sensitive, moist exterior, like a slug or a garden snail, the alkali immediately breaks down their protective slime layer. It disrupts their pH balance on direct contact. Let us set our boundaries clearly before we begin mixing. If you have a severe structural infestation, a massive termite colony eating the beams of your cellar, or an apartment building overwhelmed by bed bugs, call a professional. Baking soda is not a magic wand for an emergency crisis. What it is, plainly, is the finest, cheapest first-line treatment for small to moderate household pest problems. It is what you use to stop a small problem from becoming a disaster, entirely free of risk to your family. So, how do we take this single white powder and transform it into 30 distinct targeted remedies? How do we prepare the baits so the ants carry it back to their queen, or apply it so the fleas vanish from the rugs? The old way requires a specific understanding of how to blend, measure, and place it. Let me show you exactly how we begin. Step out of the pantry with me and come over to the old oak kitchen table. To begin using this powder effectively, you must understand that pests do not eat baking soda on its own. It has a flat, salty taste that gives them no reason to touch it. We must use their own natural appetites against them. We must blend it with the things they crave most, using specific textures and proportions that have been measured out on tables like this for generations. Let us start with the first group, the baits that rely on that internal gas buildup. For common house ants, you will need to gather two things from your cupboard: your box of baking soda and a jar of powdered sugar. The sugar must be powdered, soft as silk, not granulated. Stop and think about why this matters. If you use regular granulated sugar, the crystals are large and heavy. An ant is an incredibly precise creature. It can easily tell the difference between a square crystal of sweet sugar and a grain of salty baking soda. It will carefully separate them, eating the sugar and leaving the medicine behind. By using powdered sugar, the two white powders bond together. Their textures become identical, and the ant cannot tell them apart. Take a clean, dry porcelain bowl. Measure out exactly 1 tablespoon of the baking soda and 1 tablespoon of the powdered sugar. Equal parts. Take a wooden spoon and stir them together slowly. Watch as they blend into a single, uniform white dust. There should be no scent at all, just a clean, dry sweetness that will draw them in from across the room. Now, look at how we place it. Do not simply throw this powder loosely onto your kitchen counters. If it gets wet, it cakes up, turns into a hard crust, and loses its power completely. Instead, take a few plastic bottle caps. The small, shallow lids from old cider jugs or milk cartons work best. Spoon a small hill of the mixture into each cap, just enough to fill it halfway. Place these caps directly in the path of the ant trails you observed earlier. Look for the small gaps where the baseboard meets the linoleum, or the dark space right behind the bread box. Within a few hours you will see them arrive. They will crowd around the rim of the bottle cap. Do not disturb them. A common mistake beginners make is spraying the ants the moment they see them gathering. Understand. You do not want to kill the worker ant on the spot. You want her to eat her fill, and more importantly, you want her to carry those tiny white grains back into the nest to feed the larvae and the queen. Over 3 to 5 days, the pile in the cap will slowly diminish, and the trail across your windowsill will simply fade away. For cockroaches, we use a very similar bait, but their habits require a slightly different approach. Cockroaches are larger, hardier, and far more cautious. They prefer to feed in complete darkness, deep within the hidden hollows of your home. For this blend, you can use either powdered sugar or finely ground cornmeal. Take your bowl and mix equal parts baking soda and cornmeal. The cornmeal adds a rich, grainy scent that roaches can detect from behind a plaster wall. The mistake many folks make with roach bait is putting it out in the open where the kitchen light hits. A cockroach will rarely risk crossing a bright floor just for a meal. You must take the bait to them. Slide your refrigerator out from the wall. You will likely see a thick layer of dust and perhaps a few dark spots on the floorboards. Take your shallow bait caps filled with the cornmeal mixture and sluts them directly into that warm, dark space right near the compressor motor. Do the same under the kitchen sink, tucked far back behind the water pipes where the air stays humid. While you are under there, we can apply the dry preventive layer for the roach eggs. For this, you do not use any sugar at all. We want the pure, undiluted dehydration power of the sodium bicarbonate. Take a small hand duster, or even an old, clean dish soap bottle that has been thoroughly dried out. Fill it halfway with dry baking soda. Shake it gently, then point the nozzle into the narrow crevice between the kitchen cabinets and the floor. Give the bottle a sharp, quick squeeze. A fine, white cloud of dust will bloom out, settling into the cracks like a gentle winter frost. When newly hatched roach nymphs emerge from their hidden egg casings, they must walk through this dust. The microscopic crystals immediately begin to sap the moisture from their soft outer shells, stopping the cycle before it can even begin. Let us turn our attention to the cellar and the crawl spaces, where the crickets and silverfish hide. Crickets love coarse textures. For them, take 2 tablespoons of baking soda and mix it with 2 tablespoons of dry corn muffin mix. The sweet corn-heavy aroma is irresistible to them. Place this mixture in small, shallow cardboard trays. The lids of shoeboxes cut into small squares work perfectly. Tuck them into the dampest corners of your basement, right where the stone foundation meets the earth. For silverfish, which thrive on starch and moisture, you will mix equal parts baking soda and plain white flour. Silverfish have flat, silvery bodies that slide easily through the smallest cracks in your bathroom baseboards. They eat the starch in the flour, and the baking soda dehydrates them from the inside out. Place this dry blend in a shallow dish behind the toilet or under the clawfoot tub. Now listen closely to a warning about the garden and the perimeter of your home. When we treat slugs or outdoor pests, you might be tempted to sprinkle the baking soda heavily over the soil around your tomato plants. Do not do this. This is a critical mistake that can ruin a season's work. Baking soda is high in sodium. If a heavy rain washes a large amount of it into the dirt, it can alter the pH of the soil, making it too alkaline for your plants to draw in nutrients. Their leaves will turn yellow, and they will wither. Instead, when you see slugs damaging your cabbage leaves at dusk, apply the powder with absolute precision. Take a small pinch of pure, dry baking soda between your thumb and forefinger. Drop it directly onto the back of the slug. You will immediately hear a faint, sharp hissing sound, and the clear slime layer will begin to bubble and dissolve. It is an instant chemical reaction that stops the pest without ever touching the soil beneath it. Every one of these preparations takes less than 2 minutes to measure out. They smell of nothing more than sweet sugar, corn, or clean grain. Your hands stay clean, your kitchen remains a safe place to feed your family, and the work is done quietly, out of sight. For the cost of a few pennies from a single cardboard box, you now know how to mix the baits, how to dust the crevices, and how to place the traps so the pests find them in the dark. But there is a final piece to this traditional puzzle. To truly rid your home of these creatures for good, you must understand how to create an invisible barrier that they simply refuse to cross, using the natural mechanics of the house itself. Now that you know how to blend and place these mixtures, let us pause for a moment. Stop and think about why a simple baking powder behaves this way. To use it wisely, you must understand the underlying science, stripped of complex laboratory jargon, and you must understand exactly where this method reaches its absolute limit. When you look at baking soda, it appears to be nothing more than a smooth, harmless white powder. But under a microscope, it looks entirely different. It consists of millions of tiny, sharp, crystalline structures made of sodium bicarbonate. To understand how it acts on an insect, imagine walking barefoot across a floor covered in thousands of tiny shards of broken glass. That is what's happening on a microscopic scale when a crawling pest passes through a line of dry baking soda. For soft-bodied insects like fleas, silverfish, or the tiny larvae of carpet beetles, these microscopic crystals scrape against the delicate, waxy coating that covers their bodies. This outer layer is what keeps their internal fluids from evaporating into the air. Once that thin shield is scratched or compromised, the baking soda does something else. It acts like a tiny sponge. Sodium is naturally drawn to moisture. It pulls the water right out of the insect's tissue. In the quiet warmth of a room, the insect slowly dries out and perishes. It is a slow, purely physical process, not a chemical poisoning. This is why insects can never develop an immunity to it. A pest can become resistant to a synthetic chemical spray over several generations, but it can never become immune to physical dehydration. The stomach reaction is a different matter entirely. Think of a small corked bottle filled with vinegar. If you drop a spoonful of baking soda into that bottle and quickly slam the cork down tight, what happens? The liquid begins to foam, bubbles rise rapidly, and within seconds, the pressure blows the cork right out of the bottle. That is exactly what happens inside the digestive tract of an ant or a cockroach. Their stomachs contain natural acids used to break down food. When they swallow the bait we mixed, the alkaline baking soda hits that acid and instantly releases a sudden pocket of carbon dioxide gas. Unlike a human being, a small insect has a rigid, unyielding exoskeleton. It has no flexible stomach wall that can expand, and its primitive digestive system possesses no biological mechanism to burp, pass, or otherwise vent that trapped gas. The internal pressure rises sharply until their vital organs simply collapse under the strain. This brings us to the most critical part of our discussion: the honest boundaries of this method. I will not mislead you into thinking a $4 box will solve every disaster. We must look at the limitations with a clear, sober eye. First, look at the environmental conditions inside your home. Baking soda relies entirely on staying completely dry to work its mechanical miracles. If you live in an old house with a damp, humid basement, or if you apply this powder to an outdoor porch during a rainy spring, the humidity in the air changes everything. The dry, sharp crystals absorb the moisture from the air rather than from the pests. The powder loses its jagged edges, melts into a sticky paste, and eventually dries into a hard, useless white crust. Pests will simply walk right over it. If your problem area is constantly wet, this method will fail completely. Second, Consider the specific nature of the pest you are fighting. This powder works exceptionally well on pests that actively forage for solid food and possess chewing mouthparts, like ants, roaches, crickets, and beetles. They are the ones who will pick up the bait and ingest it. But consider a pest like the bedbug or the tick. These creatures are obligate blood feeders. They possess piercing, sucking mouthparts designed exclusively to pierce skin and draw out liquid blood. They have absolutely no interest in sugar, cornmeal, or flour. They will never eat your bait because they cannot eat solid food. While a heavy layer of dry baking soda can slowly dehydrate a bedbug that crawls through it, it is a passive, slow-acting deterrent. If you have a severe bedbug infestation inside your mattress, relying solely on baking soda is a mistake. They multiply far faster than the powder can dehydrate them. In a situation that severe, you must call a professional who can raise the temperature of the entire room to a level that kills them instantly. We must also be entirely honest about rodents. While the gas buildup mechanism can affect mice and rats, because they also lack an efficient way to relieve extreme stomach gas, they are intelligent, highly adaptive mammals. A mouse has a keen sense of smell and a natural suspicion of new food sources. If the bait mixture is not perfectly masked by the scent of peanut butter or fresh grain, they will avoid it entirely. And if a mouse finds a better source of food, like an open bag of dog food or a box of cereal in your cupboard, it will ignore your baking soda bait completely. Finally, understand the scale of your problem. Baking soda is a magnificent first line of defense for a household that sees 20 ants on the counter or a few roaches behind the stove. But if you have a colony of termites deeply established within the structural wooden beams of your roof, or a massive infestation of German cockroaches numbering in the thousands behind your walls, a few bottle caps of sugar and powder will not save your home. The sheer volume of the pest population will outpace the simple farmhouse remedy. Baking soda is a tool of patience and prevention. It requires you to observe, to mix carefully, and to wait a few days for the natural processes of chemistry to take their course. It is for the person who wants to keep their home safe, quiet, and free of unnecessary poisons before a small nuisance turns into a true emergency. Now you understand the physical reality of how the powder works, and you know exactly where it will stand its ground and where it will fail. With these boundaries clearly marked in your mind, we are ready to look at how this knowledge translates into the remaining practical applications throughout every room of the house. To truly understand the value of this simple white powder, we must look backward. This is not a modern internet discovery, nor is it a temporary trend. Stop and think about how our ancestors managed their homes. Long before the giant chemical factories began lining the riverbanks of this country, people had to rely on the basic elements of the earth to maintain cleanliness and order. The story of baking soda as we know it began in earnest in the year 1846. Two bakers from New England, John Dwight and Austin Church, established the first factory in America to produce sodium bicarbonate from sodium carbonate. Before their work, the powder was rare, often imported at great cost from Europe or laboriously refined in small batches from the ashes of specific plants. But once it became widely available in its pure, consistent form, housewives and farmers across the country immediately recognized its utility. It went into the baking troughs, it went into the laundry tubs, and very quickly, it went into the pest control routines of the early American homestead by the late 19th century. Agricultural bulletins began to document what farm families already knew through daily practice. If you look into the archives of the United States Department of Agriculture from the early 1900s or read through the old household extension circulars published by universities like Penn State, you will find constant mention of sodium bicarbonate. It was recommended as a safe, reliable means to keep ants out of dairy houses and to preserve stored grains from the destructive appetites of weevils. Even modern science, with all its advanced laboratory equipment, has had to validate these old farmhouse methods. Look at United States patent number 5,618,565, granted specifically for a pest control composition, utilizing sodium bicarbonate to eradicate fire ant colonies. When the patent office looks at a substance and confirms that a simple mix of baking soda and a mild acid can reliably eliminate an aggressive insect colony, it is no longer just an old wives' tale. It is a documented scientific reality. Furthermore, if you look at the regulations of the Environmental Protection Agency today, you will find sodium bicarbonate officially listed as a registered biopesticide. It is approved for use on organic crops because it controls fungal diseases and small insects without leaving a single drop of toxic residue in the soil or the water table. YouTube, the old folks, did not need a patent number to tell them it worked. They had the evidence of their own clean pantries and their healthy children. They knew that a home could be kept safe from creeping things without introducing substances that required a warning label or a locked cabinet. Now, look back at where we began our journey. Think of that brightly lit aisle at the hardware store, with its plastic bottles, its sharp chemical smells, and its total cost of over $110. Then look at the simple, quiet box sitting on Esther's pantry shelf. The contrast is plain, and the choice is entirely yours to make. I want to invite you to try this for yourself tonight. Do not take my word for it, and do not rely on theory. Go to your cupboard and pull out that single $4 box of baking soda. If you do not have one on hand, pick it up the next time you pass the grocery store. It is perhaps the cheapest thing you will buy all month. Pick just one pest that has been bothering you this season. If you have ants near the kitchen sink, mix that single tablespoon of powdered sugar and baking soda in a porcelain bowl. Place it in a few shallow bottle caps and slide them into their path. If you have fruit flies hovering around the fruit basket on your table, set out the small dish of apple cider vinegar and powder. Put it in place, walk away, and let the quiet laws of chemistry do their work over the next 3 to 5 days. Understand this. Taking control of your home does not require complicated solutions or expensive purchases. True self-sufficiency is built on small, simple habits that have been tested by time and found to be true. When you replace even a few of those chemical sprays with a safe, traditional powder, your kitchen becomes a cleaner place to prepare food. Your home becomes a safer environment for your children and your pets, and your hard-earned money stays right where it belongs. In your pocket, it is a small step, but it is a steady one.